Okay, so now welcome back. So now today we're going to talk about the extended power rule. Okay, so now what we're going to do is we're going to extend the power rule to negative exponents. Remember in the, I think it was Theorem 2, we talked about the power rule, but we only applied it to positive exponents. And so I went to the proof to demonstrate how the power rule here holds when we have positive exponents. Now we're going to extend it to negative exponents and show that the same power rule also applies to the case where your exponent is negative. So here's the proof. Okay, so we start off with the assumption. Okay, so that k is negative. So if k is a negative integer, what we can do is we can express it let's see, how do I want to say this? We can set n equal to negative k. Okay, so we're just going to use a different notation, since if k is negative, then we can say n is equal to negative k. Okay? So that n is a positive integer with k equal to negative n. Right? So all we're going to do is we're going to say n is equal to negative k. So that n is a positive integer, is positive with n equal to negative k. Oh, shooting. No. Yeah, here. I want k equal to negative n. That's what I want. Okay, now, since we know, right, since we know that for each positive integer, n, right, since we know for each positive integer that dx of x to the n equals n to the x times x to the n minus 1. Oh, actually, nope, I'm getting ahead of myself. I don't want to say it again. For each positive integer n, x to the n, or negative n, is equal to 1 over x to the n. So this here we should know, right? This is just a property of exponents that we all should know. right? We know that for any positive integer n, we know that x to the negative n is the same as the reciprocal, right? 1 over x to the n, okay? So now what we're going to do is we're going to apply the quotient rule by setting f of x equal to 1, right? And g of x equal to x to the n. Because what we're doing here is we're saying n is a positive integer, and x to the negative n can be written as 1 over x to the n, where n is now a positive integer. And since n is a positive integer, we can use this quotient and apply the quotient rule. And then by applying the quotient rule, we'll get the result that we want. Okay? So, let's do that. So we're going to set. Okay, so we're going to apply the quotient rule by setting f of x equal to 1 and g of x equal to x to the n. Now, so I'm going to erase this, start up here. So keep up with your notes. Now, here's what we're going to do. Now, so since we set those equal, now we know that f prime of x is going to equal 0, because f of x is 1, and g prime of x is going to equal what? It's going to equal n times x to the n minus 1, using the power rule that we for positive integers, right? So this is what we get. So if we apply the derivative, now the quotient rule, we get, so it's going to be 1 over x to the n equals, well, remember it's low d high minus high d low, so the low is x to the n times the derivative of the top, which is 0, minus the top, which is 1, times the derivative of the bottom, which is n x to the n minus 1, over the bottom squared, which is going to be x to the n squared. All right, so now let's just simplify this thing. Well, this is just going to go to 0. So the left-hand side is going to go to 0. This is just going to be n times, oops, not, n, oh, I don't want to do this. N times x to the n minus 1 over, and this is just going to be x to the 2n. Okay, now we're just going to use the property of exponents here and subtract the exponents. So this is going to become n times x to the what? N minus 1 minus 2n, which is then going to be x to the n, and what do we get? We get n minus 1 minus 2n, and what do we get? We get n minus 2n, which gives us minus n minus 1, which then gives us n to the x of negative n minus 1. Well, actually, no. Here, hold on. Nope, don't even need to go there. Because at here, we could just substitute in for k, right? So what is negative n? Well, n, remember up in the beginning, we define n equal to negative k. So So if n is equal to negative k, then negative n is equal to k. And so this becomes k minus 1. And what's n here? N is defined as negative k. So this becomes negative k. Oh, I'm missing something. Oh, I'm sorry. I forgot the negative here. I forgot the negative. So this should be a negative. I'm sorry. Something wasn't working out. So this is negative, this is negative, this is negative, and then of course this becomes positive. And there we go. There's the result. And that's it. So now we can use the power rule for both positive and negative exponents. And of course, if the exponent's 0, we don't have a power anyway. So hey, we're done. Have a great day.